Okay, I'm going to try and make another one of these for calculus. For obviously those of you doing the leaving cert. Just a reminder, this probably isn't going to be, I'm probably not going to go too in depth into what's actually happening so much. So more so it'll be more what you might see and how to answer it rather than the why behind it. It's it's probably too late at a certain point to go through it, and this is kind of just designed just so that if it's too late to be talking to me at all, that you'll have this video that you can use as like a last minute kind of thing. Again, I think I did this video with the other video. What I'm going to do is I'm going to start with what the ordinary level people are going to have, because that is important for the honours as well. But it's only a small part of the honours, so I'll start with the ordinary because it's important for everybody, but at a certain point I will say from here on in it's more so the honours stuff. The difference between honours and ordinary, you both have to do the same thing basically, but the honours is just a lot more complicated. It's the same concept overall though. So the main idea is that you're either going to start with a function that's like y equals 3x squared plus x minus 7, or one, and it might be written like this, where they have like fx equals, and it's just the exact same thing, but don't forget fx and y are just the exact same thing. And then when you differentiate it, the way it's written this way is you change that to dy dx, and you differentiate this using I'll talk about that in a second, like what I'm actually doing. I'm just getting this out of the way at the start, that there's two ways of writing it. They are both the exact same, they both come up in the exams, they both can be used as your answers. You just have to be aware that there's two different ways of doing it. And then I should actually highlight when you go into the, I know it's kind of putting the cart before the horse where I'm kind of talking about this without having said it, but the second derivative would then look like this in both examples. Doesn't really matter, they interchange them in the exam, just so you know. What I did though to get from for each stage of differentiation, and this is as far as it goes in ordinary level, it's exactly what is up here. It's on the top left of the box on page 25 of the log tables, where it tells you that if you start with an x to the power of n, when you differentiate it, it becomes nx, and the x is to the power of n minus 1. So basically you multiply in front by what the power is, and then minus 1 from the power. So when I did 3x squared, I multiplied then in front by the 2, and then lowered the power to 1, but you rarely, no one's ever going to write the 1. The power of 1 you can leave out, any other power you should write in. So for example, if it was x to the power of 7, you differentiated it, you'd multiply in front by the 7 and lower the power to 6. That's just the pattern that you do. X to the power of 13, you'd multiply in front by 13, become x to the power, or 13x to the power of 12. That's just what you do. You multiply in front, lower the power by 1. The two special cases are if there's an x on it, or if the x like doesn't have a power, is what I mean. I shouldn't say it's on its own, because it could have a number. In this example I didn't give it a number, but it could have like a 3 or a 6 or a 27 in there. But if you were differentiating, for example, just a number and a letter, when you differentiate it, it just becomes the number on its own. You drop the letter. 17x differentiated just becomes 17. If it's a minus 17x, it becomes minus 17. You just drop the letter. That's all. And then the second special case is if it's just a number on its own, like the minus 7 in my example, then you just get rid of it. If you differentiate something that is just a number with no x, it just goes away. You do not need to actually write anything else. It just, in the next line, you'll notice what I did was I didn't even write anything. You can write a 0, but like there's no need. And then the same here, when I differentiated a second time, the 1 just disappeared. And that's here. I know people don't really like the notation it's written in, but that's exactly what it's saying. It's saying whatever the n you identify as in the question, you put that in front and then write 1 less than whatever the power was as the new power. That's what you do. And yeah, that's the basics. That's on the top left, page 25, your log tables. That is all the ordinary level will need out of these two pages. Um, so I'm going to talk about like why we differentiate and what questions they might ask for it. And then I'll go into the honours stuff and kind of talk about how we differentiate in the honours, talk about first principles, all the rules, and then we talk about integration as well. Hopefully I don't forget anything. The whole point about differentiating something is you're finding its slope formula, if you remember. So when you differentiate something, you find a formula that will give you its slope at a certain point. Okay, so sorry I cut there because I went to get the actual graph to just kind of have something to reference. That's the graph of 3x squared plus x minus 7. One of the things I thought about while I was away doing that was if, as I said, if there's a number with a letter, you leave the number behind. Like when I was doing the 9x, it stays as just a 9 when you differentiate it. Don't forget, if it's just a plus x, technically there's a sneaky 1 in there. A lot of people think when you differentiate the x, you get rid of the x and there's nothing left, but there is a 1 left. Do not forget that. That's what people mess up a lot. So just to warn you, normally you just drop the x, but if you have to remember that if there's no number there, it's a sneaky 1, and you have to remember that because they will, not tell you. You have to just be on the ball. The reason why I brought this up was this green line is the graph of the 3x squared plus x minus 7. When we differentiated, we found effectively this guy here is effectively the slope formula, the m, or because we use m for slope for some reason, but the slope formula. So because the slope of this keeps changing, its slant is in a different direction at a different magnitude depending on where on the graph we pick. So you can't just say this has a slope of like 7, for example. So what we would say is, let's say you want to find the slope when x is minus 2. So you want to find the slope of this part of the graph because it's above minus 2 on the x-axis. What you would do is you would put minus 2 into your slope formula. So you take this guy, and everywhere you see an x, you put minus 2 instead, and that gives you minus 11. And you'll notice then the slope at this point here is minus 11, which kind of makes sense because it's going down very fast. If we put in 0, we'd be finding the slope of the curve at this point. And if you put in 0 everywhere you say x instead, you would end up getting 1, which makes sense because it's positive because it's going up. Remember, we always look from left to right. It's going up, so the slope is positive. And the slope is 1 because it's not as severe as this one. This one is plummeting down. This one is kind of just, it just is. So that's what the whole point of it is. It's so when you want to find a slope at a very specific point, sometimes they might ask you to make the equation of a tangent of a curve. So for example, what they'll do is they'll say, what is the equation of the tangent to the curve at the point when x is 0? And all you do is, keep in mind the tangent is a line that bounces off the curve at one point. What you do is you take your slope formula that your slope that you found from the formula. For this example, it was 1. You take the point here, which looks to be, obviously you'd have to figure this out using the proper maths, but I won't get into it. You'd use 0 minus 7 and the slope of 1 in your y minus y1 equals m bracket x minus x1 formula, where you label the first one as x1, the second number as y1, and then this is m. You sub it in, you do the maths, you get the equation of the line. But that's more so in coordinate geometry. I won't even do it right here, but it is just coordinate geometry at that point. But that's what they might ask you to do. They might even phrase it in the question where they say, instead of finding the slope of the green line at a certain point, they'll say find the slope of the tangent to the curve at that point. It's the exact same question as what I did here. You just still sub in 0, but it's just a different way of wording it. What is the slope of the tangent to the green line when x is 0? Whereas the way I phrase it, I'll be saying what the slope of the green line when x is 0. It takes longer to say it the other way, but it's the exact same thing. Is that I assume that's okay. Then it's the same with the second derivative, but the second derivative is like one extra layer into it. So this guy is like the slope of the slopes. So it's kind of describing what is, not kind of, it is exactly describing what is happening to the slopes as it moves from left to right. This one is handy because it's just 6. Sometimes you will get another formula where you'd have to sub in the x's again in the exact same way you did here, but it would just be if they asked for what the second derivative is at a certain point. The one I picked was a quadratic, so it's only going to be a number at the second derivative. So that means as you move from left to right, each slope will be an increase of 6. So because when we did this one earlier, when we subbed in the -2 and we got -11 there, I imagine the slope, I would hope the slope here will be -5, because as you moved across one space, this says that it increases by 6. And then if it goes from -5, the next one should be +1, which you'll notice is what we got when we did the maths for this one. So that's what the second derivative is. As is said, it can be more complicated though when they have, it's an equation more so than just the number 6. But again, you just sub in the value for x that you care about and you get the answer out in the same manner. Now, as I said that, right, you can sub in a value for x to find the slope at that point. Sometimes they'll pull a reverse on you and they'll ask you, when will the slope be, 7 or something. They might say, when is the slope? Yeah, when is the slope 7? We go with that one. And what you do in that scenario is you take your slope formula and you equate it to 7 because you want to know what value for x can you sub in to get 7 as an answer. Now, unfortunately for a lot of you, this becomes algebra and none of you like it. So it's just algebra though, where you want to end up with x equals at the end. So we have to use our algebra skills to keep moving things that are not the x. So you want to get the 1 on the other side. Whatever way you guys do that, you get like that. So you get 6x is equal to 6, and then you divide both sides by 6 and you get 1. So that says that when x is 1 on the graph, so 1 on the x-axis, the green line will have a slope of 7, which ties in what we said earlier, because it went from a slope of 1 here to a slope of 7 here, because as we said, the slope is increasing by 6 each time. I think it's pretty cool. So yeah, so sometimes though they'll ask you what is the slope at this point, you sub in for the x value. Other times they'll say, when is the slope something, and you equate it to that and solve it backwards like I've done here in the blue. The way that kind of works is, and this graph isn't fantastic for it, they might ask you to find where the max and the minimum of things are. I might try pause this and find another one actually that might be nicer to deal with. So I finally found one that works decently. What I'll warn you about is, this is something that a lot of people do in all the topics, not just in differentiation. You notice the graph I did, to make it look nice, I had to make it different. So I think a lot of the big problem is that everybody assumes that one box this way is the same as one box this way, but you'll notice that on my one that every box to the along the horizontal line is 1 unit, like it goes from 3 to 4, whereas the vertical it goes up in a group of 10. So you can't always just use that to go off, like for example for rise over run if you're doing it in coordinate geometry, just to get that out there while I just brought it up. They might do that to you in the exam where like they're not necessarily in the same ratio, all right? They're not in the same, it's not 1 to 1. It's not always 1 box across equals 1 box up. 1 box across equals 1/10 of a box up, if you get what I'm saying. Not too big a worry here, just so you know that's why the graph looks different to how it would normally. But what they might do is what I was going to get to at before when we were doing the differentiation. We saw that sometimes you might sub in for x, sometimes it might be that you equate it equal to it and equal to the slope they give you and solve for x to find out when on the curve will the slope have that, or will the curve have that slope. They will kind of use that sometimes as well to ask you to find the maximum and the minimum points, which on this graph obviously this would be the maximum here, like this guy. I know the arrow's not perfect, and then the minimum would be here. Now obviously it goes down further here, so you'd say, well, that's surely more minimum than that, and this is more maximum than this, but it's the local maximum, local maximum, oh my god, local maximum, local minimum, right? As in, like, if you, like, restrict yourself to, like, this area. I know you might think that sounds silly, but trust me, it's important for things. But let's say they ask you to find those. There's no real way of finding those. Well, okay, well, don't. All right, we won't get into it. But there is a sneaky way of doing it, where we know that if the line is going in a downwards direction as you move from left to right, the slope is negative. If it's going up as you move from left to right, the slope is positive. And in between those two, then, in between positive and negative, there has to be a 0. And the same works here because it's positive into negative, so in the middle there must be a slope of 0. So if they ever ask you for the maximum or the minimum, and they have been known to change the words around in the past, where they'll say, oh, find the largest or the smallest, but that's just kind of like, you know, anything that you can, like, paraphrase as maximum or minimum, you can do it this way. So what you would do is, we'd want to find out where on the curve is the slope 0, because we know that it would give us this and this as the answer. And how would we know where the slope is 0? What we do is we'd get our slope formula by differentiating this bad boy right here. We get this. Because, well, I went through it. I'll take too long if we keep going through stuff. I just get sidetracked. So you'd get this guy. So this is your slope formula. Now we want to know when is the slope 0, because we'll know that's where the max and the min are. So we take our slope formula and equate it to 0. You'll notice that when you do this, it becomes, this guy is just a quadratic that you can use the minus b for. Quadratic trinomial, some people prefer to call it. But if you use the minus b formula here, I guess I'll do it, but like you can skip this part because it's just the minus b formula. It's in a different topic. I just want you guys to believe me when I say this is what you get, because like, obviously I found the one, I know that it's going to be the right one, but I just want there to be video proof so that you guys aren't just going to say, like, well, you never showed us. Hopefully you all know how to do the minus b formula. At this point, again, I'm going to rant about your calculators all being super good, and then you guys all giving out about it. What would we, well, when you type all of this into calculator, you do it once when there's a plus in this situation, you do it once where there's a minus there. When you do the plus version, well, so then you'd get 5 when you do it the plus version. When you do it the minus version, then you would get 1. Yeah, 1. So what we're saying is, if we want the slope formula to give us 0 as an answer, it must either be we sub in 1 or we sub in 5 as the x value. So that means we know that the minimum and the maximum occur when x is 1 and when x is 5. So when you get to those numbers on the x-axis, and you'll notice that does match up with the graph. Maths is cool, it all makes sense. So yeah, when you equate the first derivative equal to 0, it will tell you the x values for where the slope exists, or for where the slope is 0, or where the minimum or maximum exist. Now, obviously, because we have the graph here, we can tell that the one that exists when x is 1 is the maximum, and the one that exists when x is 5 is the minimum. Sometimes we have to figure out that, but that's what the second derivative is for. We'll talk about that. If you want to find the y value for the max and the min, as in what height these 2 points are at, you take these guys and sub them back into the original. If you sub them back in here, if you sub 1 in, for example, what would you get? You'd get 1. Oh, hold on. You get 3. So if you subbed in 1 for the x, you'd get 3 as the y, which kind of makes sense, because if you look at this looks like it's at a height of 3. So the coordinates would be 1 and 3. And when you do it for the 5, I think I remember it being minus 29. So down here you'd end up with the point of 5 and minus 29. So even if you didn't have the graph, if you figured out that one height was at 3 and one height was at minus 29, Obviously the maximum is going to be the one at the 3 because it's higher up than minus 29. That is like a shady way of doing it, of finding out which one is the max and the min from here. I will warn you, sometimes they ask you, so sometimes they'll ask you what's the x value for when the slope is 0, sometimes they'll ask you what the y is, that what the actual answer is, and what you have to remember to do is take these guys and sub them back into the original to find the corresponding y value. Do not take it and sub it into this guy. Good lord, this guy is just the slope formula. It'll just tell you 0. Do not. The amount of times people do that. But let's say they're dastardly about it. What they might do is, which is the max and the min, using the second derivative. So what you do is, you take this guy down again, and you differentiate it to get the second derivative. When you differentiate it again, you get 6x minus 18. Now, here's the bit that people don't like, but again, I'm not really getting into it. We're just going to talk about it. If you want to find out the nature of which one of these gives you the max and which one gives you the min, what you can do is just sub them in here. You notice when you sub in 1, you would get minus 12. And when you sub in the 5, you get, you weirdly get plus 12. Don't you? You do. I hope that's right. But the idea is one is going to be positive, one is negative. That's the most important thing. We don't actually care about the numbers. If it's a positive number, it's a minimum, and if it's a negative number, it's a maximum. It's kind of the opposite to how I think of it, how it should be. But when you get into the maths, obviously it don't make sense. But it's on the surface of it, you'd automatically think if it's a positive number, it must be maximum. But for the second derivative, it's the opposite way around. Just remember that. So you'll notice, yeah, when we subbed in the 5, we got a positive, which means the minimum, and the minimum does occur when the x is 5, and then vice versa. You get a negative for 1, so it must be maximum, and the maximum does occur when x is 1. So for the second derivative, it's a way of telling which is the max and the min, but it works the opposite way around to what you think. Is that all I want to do for that? Sometimes if they ask you for a point of inflection, I can't remember how often they do this in ordinary level, but I think I have seen it before. Point of inflection is the point in the middle of the two, the u and the n, and basically all you do is you take your second derivative, and you equate that to 0 instead, in the same way that we would have done for above, for the max and min, but that's the first derivative. Second derivative equal to 0 will tell you the point of inflection. And you do the maths where you bring the 18 over and you get 6x equals 18. You divide both sides by x, or by 6, good lord, and you get 3. So, oh, would you look at that? It's, oh wow, that's crazy. When x is 3, you get the point of inflection. And again, if you want to find the y value, you take that guy and sub it back into the OG, into the fx, and it'll tell you whatever the y value is. That's for points of inflection. I think there's one more part I have to talk about ordinary. I think I'm forgetting some things. If I forget something, I'll come back and try my hardest to edit it into it, but like God knows how that will go. The last thing that they're talking about, I think, in ordinary level is this idea of SVA, right? Now, upsetting to most people, that's distance, speed, acceleration, right? But they use displacement, velocity, and acceleration instead. Obviously, in most people's heads, it should be distance, speed, acceleration, but just be warned, it won't be. And if they want you, what they might do is they might give you a formula called S that has t's in it. Don't forget that's how that works. And they'll say, oh, it's 3t squared minus 12t plus 5, you know. And in your head, you have to remember that's distance, or maybe they'll give you a height formula and use h here instead. But that's what that means. If they say what's the distance that's occurred in the first 5 seconds, or how far has it traveled after 5 seconds, or some shit like that, you basically just replace the t with a 5, and that will tell you how far it's gone after 5 seconds, because that's the distance formula, if you follow me. And you can do all that maths out. What is that? 75 minus 60, 50, 20 or something, maybe, I don't know. The idea is that's the distance it's traveled after 5 seconds. If they asked you for the speed after 5 seconds, that just doesn't work, because that's just not the speed formula. Don't forget S, it doesn't stand for speed here. To get the speed formula, we need a formula with V in it, and in order to do that, in this triumvirate here, as you move from left to right, you differentiate. So if you wanted to find out a V formula, you take your S formula and differentiate it. Just doing S-T in the same way you did F-X, you could do ds dt if you want, that's fine also. But you differentiate it just like you normally would, and there's your speed formula. And what you would do is you'd sub 5 in for that if you wanted the speed after 5 seconds. And you would get this, which is, you know, the 18. So it's traveled 20 meters or whatever after 5 seconds, but it's going at a speed of 18. And then if, again, they wanted the acceleration, you take this guy and differentiate it a second time. Sometimes they might start you with the V one, you only have to differentiate it once. Just be warned, you know, that might be what they do. You notice here again, it's just a number. Sometimes it'll be an actual equation, sometimes it's just a number, and that just means the acceleration is always 6. If it's an actual formula, again, you'd have to sub in the 5 or whatever they asked for. But just know that if you want to go from left to right in SVA, distance, speed, acceleration, that's how it works. Okay, again, with that stuff they might do it, but that's more functions where they'll say when is the speed a certain speed, and what you'd do is you'd find this formula first and then equate it to, you know, whatever they ask. It's just the same as what we did earlier. It just turns into algebra. You just have to solve for t at that point where you move everything that's not t. Okay, I think that's all of ordinary level. I think, as I said, if I find anything that I forget, I will come back to it and try edit it in before this point where I say I'm going to start everything I do from now on. It'll just be honors. Yeah, hopefully it won't take too long. I know these videos are a lot longer than like I want them to be. I just get into the maths and I just forget that I maybe shouldn't be going as in depth into it. Maybe I should be going more in depth, splitting it up. I don't know. I do not know. I don't know. I'm sure you'll complain either way to me, so it'll be grand. Okay, so this is the cutoff point for ordinary into honors. And what I'm going to do is, even though it's probably not the right way around to do it, I'm just going to kind of commandeer this. In honors, don't forget, I won't get into the integration just yet, but just remember that in honors you can go the other way around. But it's like you differentiate this way. Probably shouldn't do that in that color. Differentiate this way, dy dx, and integrate this way. So sometimes they might start you with the acceleration formula and ask you to go backwards. As you move right, you differentiate, integrate, you move left. But I won't get into integration just yet. Just remember that's the order of it. It's still the same concept. Yeah, okay, I guess, sorry, I'm all sorts here now because I just had to go through it all and now kind of go back to the start again. I guess for honors first principles, I won't go into it hugely because again, this is just a reminder of what you have to do. If they mention in the questions differentiate from first principles, you have to do it this way, else you lose marks. The whole process is you christen what they give you as fx in the question. Sometimes I've seen them do this before where they'll give you like this kind of crap. They'll say in the question differentiate this from first principles, and what you do is you christen that fx, but before we do anything you'd multiply it out just to make it kind of nicer on you, so that you don't have to do like just horrendous shit. Like it's just better, trust me on that. So your first step is christen what to give you fx. If it's something handy like that, just do it out. It'll be a lot easier if it's just written like this. Then you find f of x plus h, which is all you do is you sub x plus h everywhere you see an x, like so. You multiply that all out as you should. Hold on. Now I said 4xh, but you can write it as hx. It does not matter. Really. So yeah, you christen fx, get f of x plus h, then you do f of x plus h minus f of x, and all that's really going to happen here is, you notice when you take this guy, I'm not going to write it all out if that's okay, you should in the exam, but if you take this guy away from this guy, all that's going to happen is you're going to minus 2x squared from this, so this will go away. You're going to minus 3x from this, so this will go away, and you're going to minus a minus 9, so it's going to be a plus 9, and then this will go away. And you should only be left, if you've done it right, you should only be left with the things with the h's. Now, I'm not going to say that that's just a rule you can use, because again, you should probably try write out as much of this as possible. Just, you know, get the marks, get, you know, the temp marks, make sure that it doesn't look like you've just copied it off someone. Then your next step, again, I'm going to squeeze it into one thing, but you should write this out a second time. You divide that by h. That is a h, by the way. And all that happens is everything gets divided by h. 4xh divided by h is just 4x. 3h divided by 3 is just 3. But 2h squared divided by h is plus 2h. And then the last step, and you do need to write this, the limit as h goes to 0 of fx plus, you know, all this crap again, over h is equal to, and then what you do is you just replace all the h's with 0. And 2 times 0 is 0, so you're just left with 4x plus 3. And you'll notice that is, you can always check first principles, because you notice if you differentiated your thing in the question, you would have gotten to this anyway. But we just need to show that we can do first principles. Is it just a good way of checking it? It doesn't, you can't, if you do it just the normal differentiation way, you won't get marks for it. So do it this way. It's just, it's handy marks. They very often throw that out into the mix. Just remember your steps, slap them down, do it as best you can. Now, another thing I want to talk about is how, as I said for the other ones, I don't know if this is news for the honours people, but the ordinary only need this guy. Obviously in honours, technically you need all of this, and then I think here it's only really kind of like this, well, I missed the sin x, but this kind of stuff. You know, they've taken off this bit off the course, that's for sure. This stuff, like, I think it did come up in a mock one year, but like, you know, basically if you see something on the left hand side of one of these boxes and you need to differentiate it, it just becomes the right hand side version. If it gets too in depth into it, just no one's going to get it anyway, so it won't really be too big a deal. But just remember, if you can't remember which one is differentiation and which one's integration, the first one in each thing will kind of give you a quick hint. The idea here is if you have anything that looks on the left hand side, you can turn it into right hand side. We'll talk about that a bit for the chain rule in particular. Remember, the product rule is used when they ask you to differentiate two things that are being multiplied together. I'm going to actually just use this guy as kind of like a cheat, because it is two things that were being multiplied together. What we would do is, like, just pretend we were asked to differentiate this. You could christen this u and you could christen this v. So you'd say u is x plus 3. You could say v equals 2x plus, minus 3. You have to find du, dx, that's something else maybe I should have said earlier. But basically the way differentiation works is whatever letter is here goes on top of the fraction, whatever letter is in the thing goes on the bottom, so that's why that's du dx. When you differentiate that, it's just 1. When you differentiate this, it's dv dx. That just becomes 2. It's probably not the most complicated one I could have picked, but then you sub into the formula. Basically the formula has 4 parts in it. It has the v, the du dx, and the u and the dv dx just being added together. Just fill in that formula. Now, you know, you'll be able to look at it on the screen and what you've written at the same time. I can't, so you just fill in the formula though, and you'd end up with u multiplied by dv dx plus, and then v multiplied by du dx, and you get this, and then you multiply that out, you get this. And when you add like terms, you get 4x plus 3. But oh my god, that is the thing differentiated. Wow, that's crazy. Now for those ones, it's probably easier to just multiply it out and then, you know, differentiate it that way. But for an example of when they're multiplying two things together, it might be like 2 sine x because we're multiplying two things that have x's in it, because if you think about it, that x is stuck inside of a sign, so really we're multiplying this guy by this guy. Two things with x's within them being multiplied together, we'd christen one u and one v. Du dx would be 2, dv dx would be the cos x, or whatever the box tells you it turns into. Yep, it turns into cos, there we go. The quotient rule is the same basically as the product rule, but instead of when you're multiplying two things, it's when you're dividing things. You christen the thing on top u, you christen the thing on the bottom v, differentiate them both to get du dx, dv dx, slap them into the formula, fill v in here as well, and square it. Common practice in the actual leaving cert is that we don't square out the thing on the bottom. You just leave it as whatever v is, you just put it in a bracket and then just slap a squared after it, and you're just kind of considered to be done. I think like it's just, you know, it's tidier, and there's a chance that you could have things cancelling out. The chain rule, good lord. Basically what the chain rule is if you ever see anything that looks like it belongs here, but in everywhere the x is, there's something more complicated. Like for example, let's say the ln of x. Imagine they had a ln of 2x plus 7. Or for the sine, they had sine of 3x squared minus 16. Or as I saw in one exam in 2018, you had to do this guy here, and you notice that's just this one where the x is vastly more complicated. So as soon as you see something that looks like it's on the left hand side of that box, but the x has been replaced with something awful, it's the chain rule. Another example would be, see this top one where the x has been replaced? This is probably the most common one that you'll come across. If you see like this, you'll notice that's like the x in here has been replaced with something. So the minute you see any of that, we are going to use the chain rule to figure it out, because it's like a function has been put inside one of the other functions that we were going to differentiate. What you do is you christen the inside one, the one that looks like it's been subbed into one of these guys as v, and then one of these guys will be the u, right? So in the very first example, we would say v is 3x plus 4, u would be v to the power of 9. U always has to have v in it. U is always the original thing, just with, you know, v swapped in for whatever you said v was. Here we'd say v is 2x plus 7. U would be ln of v. Here v is 3x squared minus 16. I just made all these up. These could be absolute garbage numbers. But you get the gist of it. And then v is equal to minus a half x squared. U is equal to e to the power of v. Alright, and then the idea in the chain rule is you multiply du dv by dv dx to get your answer. You'll notice that dv dx is what happens when you differentiate the first one, because you have v on it to the left and x is in it, so that would give you dv dx. Yeah, dv I guess I'll do it for the last one. Dv dx is handy to differentiate here. You multiply down in front by the 2. Minus half by 2 is minus 1. And then, oh god, Jesus, the x, you lower the power by 1. So I'm not going to write in the 1, but yep. And then du dv, for the u one, it's always going to be like something here. So you notice e to the power of x stays as e to the power of x, so e to the power of v will stay as e to the power of v. And then chain rule just says multiply your answers. So the answer to differentiating this guy is the minus x multiplied by e to the power of v, but you never want to leave v in your answer. You swap that back out for whatever you said v was in the first place, and hallelujah, there you go. That's dy dx for the e part. So that's how you do the chain rule. I hate the way they do it, and I hate the way that you guys all accept it, because these are all terrible people. A few of them have changed, in fairness. Now I'm not gonna, there's a few teachers that I'll take it back. But another thing I want to point out, in 2018, when they had to differentiate this, I kind of lied. They technically had to differentiate this, right? But the thing is, that has no x's in it. I know it has a pi and a square root and a fraction, and it looks icky, but it's really just a number in disguise. So it's really just a constant, a number that's just been thrown in front of it. It would be the exact same if instead of all that, they had just thrown a 3 in front of it. You differentiate it and just multiply your answer by a 3. So what we would do is, with the original guy, we would differentiate the thing again and just multiply the answer by 1 over root 2 pi. That is only the case if there's no x's in it at all. If it's simply just a number, and I know pi doesn't look like a number, but as we all know, it's 3.14, whatever. So that's what that is. In 2018, they were then asked to differentiate that a second time to get the second derivative. Again, ignore the 1 over 2 pi. We're going to differentiate the blue part, and then just remember to stick a 1 over 2 pi multiplied by everything at the end, right? You'll notice in here we have two things now that have x's in them being multiplied together. So this is actually the product rule. I'll change color, I know it's kind of a mess. But we would say u, because product rule is two things being multiplied together, would be minus x. V is e to the power of minus a half x squared. This is the hardest one I've ever seen them ask you to differentiate, by the way. I wouldn't be too upset if you see this and you're kind of like, I wouldn't know. Just know that I'm trying to do, everyone gives out that the teachers did the easy example and they made us do all the hard ones. I'm doing the hard one here in the hopes that it will just cover all, but maybe it's too hard. But you see here where I differentiated u and now I'm on to differentiating v, and that's atrocious. So technically what I could do is, I guess I'll just get a different color for this. I could take this as an aside and do, because you'll notice this is a chain rule situation. There's a thing subbed into the e to the power of x. So I do the thing where I call v, I'm making a mess of it because I'm not actually going to write it here, right? But I'd say v is that u equals e to the power of v, differentiate both things, get your answer, sub it back in here. And that's something they will do sometimes, where you have to do a chain, or you have to do a rule inside of a rule. I would advise you kind of, as an aside, do it somewhere else, like as if we zoomed in on just a separated kind of version, so you don't mix up which u and which v is which. It's easy for me because I have the colors, but when you have the same color pen, it's going to be a mess. But if you were super sly that year, you could have noticed that differentiating this guy was actually what they asked you to do in the first place, where they asked you to differentiate the first guy in the question. So down here, you actually didn't have to do that if you didn't want to. You could have just spotted, well, when I differentiated this guy, I got this as an answer. So that's what I'm going to have. Now, a lot of people do not like that it's like recursive, that its own answer is used in it again and again, but I don't know what to tell you, that's just how it is. And then you do the product rule, which means multiply u by dv dx, multiply v by du dx, and it just becomes a big mess. But that's what they wanted you to do. I won't really get into too much of the algebra, because if you get to there, Christ, you'll be better than most. But that's what they asked you to do. And that's basically the hardest kind of differentiation you're going to get. Hopefully, I think that's okay for the rules. The things here are hopefully okay. They're fairly self-explanatory from the box. Am I forgetting any? Because it's all basically the same as what I did earlier in the ordinary one, but it's just kind of like much harder process of getting from fx to f-x. After that, they could still ask you to just do the subbing in part or equating it part, finding the max min, finding the point of inflection, finding out when is the curve this, finding out when is the slope of the tangent to the curve at a certain point, whatever. So sometimes you have to sub in for x, sometimes you have to equal it to something. Now keep in mind, maybe I should have mentioned this at the very start as well. Another way, they might say, to differentiate, they might say when is the max or the minimum, they might say derivatives, they might say differentiate, they might say calculus, they might say find the rate of change is probably the most common one. Find the rate of change of this function, or they won't word it like that, but they'll say find the rate of change. Now, they've given you a function, just means differentiate. If they say find the rate, I should have. No, it was fair. I think it was obvious enough actually. If they ask you to find the rate of change at a certain point, you differentiate and then sub in. Do not sub in first, please. So for now, I'm going to jump onto the integration. I hopefully haven't forgotten anything. I'll try look back at it afterwards and just make sure. If I have forgotten anything, obviously I'll add it back in. Hopefully, if I figure that out. But as we all know, obviously, integration, this bad boy with the curly S, is just differentiation backwards. So as long as the power is not -1, because that's technically this 1 over x, then you have to follow this differentiation. Or this fucking integration, Christ, sorry. It's the opposite of differentiation. If you have x to the power of n, you increase the power by 1 and divide by that new number, whatever n plus 1 is. It's the same kind of way backwards that for anything on the left, if you want to integrate it, it turns to the right. There is one issue actually. So basically, if you do the chain rule for like a sine, cos, or tan, and inside the sine, cos, or tan is only a number and a letter, you'll notice when you do the chain rule and you differentiate the 3x and multiply it by it, you'll end up with just this 3 multiplied by whatever sine changes to as cos. So you'll end up with this. If you differentiated, for example, cos of 7x, cos changes to minus sine, but the chain rule says you have to multiply in front by whatever this differentiated is. Just don't worry about it when you do that, and you multiply by 7. So even though I think you should do the chain rule each and every time for that, what they will accept is if you're differentiating sine or cos with just a number and a letter, do not try to do that for anything else, just a number and a letter. You just slap the number at the front and differentiate the sine or the cos, whoever this tells you to do it over here. And the reason why I wouldn't have told you about that, because I want people to use the chain rule every time just to be safe and for practice, and I don't trust you enough. But it's weird because if they ask you to integrate cos of 3x, for example, and don't forget you always have to have like the dx here. They won't mark you down for it, but just that's why it's there. It's like the end bracket for a squiggly s. Just, you know. If they ask you to do that, the answer is, well, cos turns into sine. So it'll be sine of 3x. And in the same way that earlier we saw for differentiation, you'd multiply in front by 3 because integration is the opposite, it's the backwards, you divide by 3. Obviously, yeah, well, I'll talk about that separately. But if you integrate a sine, cos, or tan, that's like the one edge case here. If you integrate sine, cos, or tan with a number and a letter, just divide by the thing. We won't really go into, you never go into why that is in the course anymore. They take enough out of integration that it's just not worth it. But just know that if you integrate sine, cos, or tan with a number and a letter, you just end up dividing by that number after you integrate the cos or the sine or whatever it is. The plus c, don't forget you always have to add in if there's no limits. If there are limits, do you know what? I'm just going to use this guy because he's just chilling here. If there are limits, you don't need to put in the c because it would cancel out anyway eventually. Don't worry about it. But just remember that if you are using the limits, what you're doing is you're finding the area between the curve and the x-axis. So here, let's say we integrated this guy up here. I had taken this as like from 1 to 3. Well, the bigger number always has to go on top, my apologies. 3 to 1. What you're doing is you're kind of cutting it into here, where 1 on the x-axis, 3 on the x-axis. I know, they're not fantastic. Oh yeah, I could have done that. And what you're doing is you're finding the area between the curve and the x-axis in that scenario. So you're finding the area in here and in here. Now, if it's a situation where it's always above the x-axis, you're fine. However, here you'll notice there's 2 sections. One is below the x-axis. So what you'd have to do is you'd have to find out where does that cut again, maybe I didn't pick a nice one. You'd have to find out the x value for where it cuts the axis. And then what you do is you'd split that up so that you'd integrate it once between, let's say that's like 1.8 or something. I don't know what it is. Don't go by that. You'd integrate it once between 1.8 and 1 to get this guy. And then you'd integrate it again between 3 and 1.8 to get that guy. But just remember that when you do the upside down one, you'll get a minus number. So when you do the upside down one, that's why we have to do it separately. You get a minus number here. What you do is you turn that guy into a positive regardless, because it's a negative because it's underneath, but we don't really care. We care about the area. So you turn it into a positive and add it to whatever you got in the first one. Remember that when you're doing integration with limits, what happens is, like for example, you integrate it. Yeah, there has to be the thing. When you integrate it with the 3 and the 18, you then do it once where you sub in 3 everywhere you see an x, and then minus everywhere you see an x, you sub in a 1.8. You know, I don't know. Let's just pretend it a bit. This is what you would do. Everywhere you see an x, sub in one guy. Everywhere you see an x, sub in the 1.8 in the second one. 3 in the first one, the second. Top one goes in the first bracket, bottom one goes in the second one. Because the biggest number is always in top, smallest one's always in the bottom. And you'd get like that, and you do the maths. And I know I picked random maths numbers, so it might not work out the way I wanted to, but you should get a negative number when you do this if the thing is underneath the graph, like it would have been for this one. What other thing was I about to mention there? Yeah, so the most common way of doing it is most common way of doing it in a question that I've seen is, what they'll say is they give you a function question like before, where or you know those examples where they'll say like the population of a city is given by this formula or this function. They'll ask you for like, what's the population at this time? You sub in when will the population be this, you put it equal to that and solve for t. They might ask you what's the rate of change, in which case you differentiate it and sub in a certain number that they ask you to. They might say when will the rate of change be, whatever. So you differentiate the thing and you put it equal to that, you know, all that good stuff. And they might say then at like the end, they'll say like, what's the average value, what's the average population between 2010 and 2025, or something was used, one of the questions. So what you'd do is you'd integrate you'd integrate between those 2 years where those are your limits. I think in the question I'm thinking of, it wasn't that you put 2025 and 2010 as your limits. You put 15 and 0 as your limits because they considered it from the start of 2010. And you divide by however many years or time or hours or whatever the fuck has passed. So you would then divide that by 15. So you'd integrate with your limits being the 2 endpoints, and you divide by the gap in between the 2 endpoints. That's if they ask you for the average value and they've given you a function in the question. That's what you do, okay? Otherwise, the maths is pretty simple, so I'm not going to do it out. The way they describe it in certain books or certain teachers might write it is, and I don't like this way because I don't think you'll understand it. They say if they ask you for the average function, write it like this. I'm just kind of writing this so that you can recognize it if this is the way you prefer to do it. They'd say integrate fx in between b and a and divide what the difference between b and a is. Because that's kind of how you find the average. You find the total amount that there is, divide by the amount of gaps. Okay. There's one more thing I want to talk about that I can think of at the minute. I might find more things to think about, but as I said, hopefully I'll come back if I can figure it out and I know what to do for editing it. I don't know. But what they do in ordinary level instead of integration, so they don't do integration in ordinary level, what they do instead is they use this thing called the trapezoidal rule. And it's technically on the course for honours, but it's not as accurate as the integration, so they don't really teach it anymore. However, the past few years what they've started doing is they've started throwing this into they started throwing a couple of ordinary things into the honours because they know that you kind of aren't taught it anymore and they want to catch us off, which I don't really get. So it looks like this. You'll never need the Simpson rule. You can ignore that. Obviously, you can cut out the Irish just so like it doesn't look as horrendous. And what the whole trapezoidal rule is it's an area formula if you have a weird shape that doesn't have like a fixed formula, like the circle or the squares or rectangles or cones or all that type of good stuff. If it's like a weird ass shape that just doesn't have one, which you'll notice looks like the graphs, is done on purpose, then you can estimate it by using this formula. The area is kind of equals. You notice it's a wavy equals to signify it's not fully perfect. integration is the perfect form of this, because in I'll tell you in a second. But the idea is that whatever shape you're given on the graph, you split it into like these funky looking rectangles. Now obviously it's a perfect rectangle here, here, and here, but obviously like not like here. So what the maths does is, I won't go into it too much, but what the maths technically does is it kind of like makes it as best an estimate for the rectangle as possible, and it does it for each one of them, and then it adds all the areas of those rectangles together. So it's not perfect. I don't know, are we still yeah, we're still recording. There's something wrong with the internet. Are we good? Yep. So it's not perfect, but that's why it's an estimation. Now normally what they shouldn't really ask that then if it's not perfect and you have a better way of doing it, but what they like to do is they'll ask this and be like, how much better is the integration? What percentage error was there in the trapezoidal rule? I don't know why. I think they're genuinely just trying to catch you out. It doesn't seem like a decent actual attempt at getting us to learn maths. It just does seem like it's trying to catch you out. Now you'll notice they stopped splitting it into rectangles at a certain point because they don't know how many rectangles you want to split it into. You could want to split it into 4, you could want to split it into 5, 7, 26, you know. So they do the ... to signify that there could be any amount here, and yn just represents their last one, whatever. So y1 is your first one, y2 is your second one, so on and so forth, until yn is your last one, whatever that is for you. If it's split into 8, your last one is 8, n is 8. Because then in the formula, y1 is, you know, y1, yn is just your last one, and then it says plus 2, and just throw in the rest all the way up until yn minus 1. If your n was 8, 8 minus 1 would be 7, so they're saying do it all the way to y7, which would be like the second last lad, if you get me. The n minus 1 here means second last one. It does not mean sub in whatever y8 is here and then take away 1 from that. No. Take 1 away from whatever the n is and then find out what y that is that they want. But the basic idea is first one, last one, go here and here, everything else goes in here. H, of course, I forgot to say, is just the width of each rectangle, and they should all be the same width. And that's just what number goes here. And that is your guess at the area under that curve. But as we remember, that's what integration is for. Integration is a lot more accurate because effectively you're splitting it into an infinite number of rectangles, which, you know, the more rectangles there are, the skinnier there are, the more accurate the rectangles would be to the curve. Yeah, just to warn you that they might throw that in as a part A, and then part B will be now to use integration to do it and just see how much it's off by. Okay, I think that's everything. Again, I'll look through it. I'll have an idea. I'm conscious these videos are quite long. I'm just trying to figure out what's best. So, yeah. One last thing, don't forget for integration they can use the word antiderivative. Antiderivative, a derivative is what you get when you differentiate, and antiderivative is what you get when you integrate. Is what you get when you integrate. Yeah, you get it. You get it. Sure.